The James Webb Telescope has, as of late, sent a stunning message that has left all NASA researchers flabbergasted. The best optical telescope in space has been noticing various pieces of our colossal universe for a truly delayed time interval, uncovering different irregularities any way the new picture it has made a wave through the universe of science and cosmology. What surprising picture has the James Webb Telescope caught? Might it at some point have shot an extraterrestrial rocket in the farthest reaches of space? Go along with us as we investigate the disturbing new pictures that the James Webb Telescope has revealed, pictures we have never seen previously, on the off chance that you're amped up for remaining totally informed about news from the universe and its environmental components. Buy into our channel, like this video. Furthermore, turn on notifications. NASA's 10 billion James Webb Space Telescope was sent off from the European spaceport in French Guiana. When it showed up at its new amazing home, this infrared observatory provided stunning perspectives on the universe to investigators and stargazers as the most prominent and most exceptional space telescope to date. Examiners were energized to see the main logical pictures caught by the telescope. What they saw almost left them frozen when the James Webb turned its instruments toward the notable pillars of creation. It caught the well-known dust mists in perfect detail. These pillars are situated in the group of star serpents around 7,000 light-years from Earth. The pillars of creation are part of the Hawk cloud, huge billows of gas and residue that were first imaged by the Hubble Space Telescope in 1995. From that point forward, the brilliant shine of the pillar points has been uncovered. The new photo caught by the James Webb Space Telescope reveals the pillars of creation in much more critical detail. A few stars are visible that were not seen in the previous picture caught by Hubble, some of which formed 2 or 3 million years ago. This represents a huge logical progression. The James Webb Space Telescope has also inspected the alleged Pandora's cluster in a shocking picture. Named after Greek folklore, Pandora's cluster is a district predicted by Albert Einstein in 195. These new pictures surprise researchers as they reveal subtleties previously unknown about this area of space. Anyway, it is important to note that this area of space has a formal name known as SMX 0723, which is part of the Pandora cluster. This cluster houses a mix of unmistakable designs inside it. What is so intriguing about this picture is that it's been seen before. However, just the central piece of space has been analyzed by the Hubble Space Telescope. This suggests that other astronomical mysteries still need to be found in this entrancing region of space until the James Webb directed its powerful infrared instrument to the area to notice the Pandora cluster. The noticing group utilized the huge telescope's close to infrared spectrograph and close infrared camera as a part of the deep perception program. Before the ionization epoch, pictures were taken and then at that point combined into an all-encompassing picture. This all-encompassing picture revealed around 5,000 infrared light sources in the Pandora cluster, which is about 3.5 billion light-years away. The picture caught by the James Webb Space Telescope accomplished a remarkable concordance between depth and expansiveness, which could change our perspective on grandiose development. A feature of the picture is a brilliant forefront star in the smooth manner, whose exceptional diffraction design was created by the James Webb Space Telescope. Likewise apparent are brilliant sources of white light encircled by a dim shine, relating to significantly more far-off systems inside the Pandora cluster. Although human-made technology is crucial for the perception of this universe cluster, space experts also relied on a natural peculiarity proposed by Albert Einstein in his hypothesis of gravity known as general relativity, published in 1915. Moreover, interesting revelations continue to captivate researchers and space experts. The James Webb Telescope has caught unconventional astronomical peculiarities that indeed even specialists can't fully explain. One such mystery is the confounding concentric rings tracked down around a far-off star which still can't be totally understood by space specialists. The picture was posted on Twitter by a resident scientist, starting a storm of remarks and discussion among the online community. The image showed a star called WR140 surrounded by normal wave-like circles that gradually faded. What was striking was that the circles were not entirely round but had a fairly square appearance. This quickly led to speculation about a possible extraterrestrial origin. Anyway, some experts contended that it was simply nature performing something that seemed phenomenal when seen from a single point of view. Sometimes natural peculiarities could appear to be dynamic from certain perspectives but have straightforward explanations. By questions remain. Why do they have that particular shape? And why are they so ordinary? These questions have puzzled specialists like Mark McCann, an interdisciplinary analyst with the JWST Science Working Group and a science guide to the European Space Organization, who called it amazing. In a Twitter thread, he explained that the sharp blue pattern is a relic due to optical diffraction from the bright star WR14 in the picture. Regardless, he noted that the red twist is real and represents a series of shells around WR140 in space, despite the fact that NASA is expected to provide an explanation soon. Young stars generally tend to radiate brightly blue, while over time they take on a redder glow as they consume their fuel and cool. Cosmologists didn't anticipate seeing old red stars in the early universe for which the James Webb Space Telescope was designed, nor did they hope to see systems up to multiple times more gigantic than the Sun. These red spots uncovered in the pictures caught by the James Webb Space Telescope seem by all accounts to be ordinarily more monstrous, as indicated by Jan Kai. The most monstrous system in our sample is estimated to have masses between 2 and 3 times less than that of the Milky Way. She said this discovery is shocking, since galaxies as extensive as our own were found when the universe was only 3% of its current age. Leah also mentioned that before cosmologists begin changing cosmological hypotheses to explain how these systems form so rapidly after the Big Bang, they will need to ensure that the impossible to miss red spots they are observing are not something else. Otherwise, alternative explanations would also require groundbreaking ideas. For example, stars in the early universe could produce light in unusual ways because of a lack of heavy elements not included in our models. The pictures that revealed these baffling worlds were captured by Webb's close to infrared camera as part of the large early release science program. The group plans to return soon to these systems in the SMAC 0723 cluster to obtain spectra of light from far-off sources. The spectra decompose the observed light according to its structure into frequencies, thus revealing the chemical and physical properties of its source. Remarkably, the spectra provide very precise distances to these objects. The distance and nature of these objects are interconnected, and if we know the distance, we can pinpoint their qualities. Leah states that just a few months after Webb's team released the initial perceptions, researchers are being forced to revise hypotheses about the early universe. Noticing the early universe for the first time led us to discover something so surprising that it presents issues for science in general as it challenges the whole picture of early galaxy development. Another astounding picture caught by the James Webb Space Telescope, shows the phantom galaxy, which seems to be a whirlpool turning before our eyes. This new picture based on deep space data highlights the dust paths of the universe NGC 6208 or M74, also called the perfect spiral, due to its balance. The phantom galaxy is intriguing from a scientific viewpoint because of the massive black hole researchers believe is at its center. Although the phantom galaxy has been imaged several times, including by space observatories like the Hubble Space Telescope and the Spitzer Space Telescope, Webb's pictures stand out because of the near-infrared light that uncovered immense dust combined with the power of its extraordinary 18-segment hexagonal mirror. The James Webb Space Telescope, hailed as one of the most aggressive endeavors in space exploration, continues to astonish researchers with its extraordinary abilities and discoveries. Launched with a mission to uncover the most profound secrets of the universe, Webb has not disappointed in its initial perceptions. From catching the multifaceted subtleties of distant galaxies to uncovering previously hidden peculiarities, Webb's contributions to space science are rewriting the textbooks of our understanding. One of the telescope's remarkable accomplishments is its ability to peer further into space than any other instrument before it by harnessing its advanced infrared technology and using a huge 18-segment mirror. Webb has opened a new realm of exploration unlike its predecessor, the Hubble Space Telescope, which primarily worked in the visible and ultraviolet ranges. Webb's infrared capabilities allow it to penetrate massive dust clouds and observe celestial objects hidden from optical telescopes. This ability has proven essential in its observations of the famous pillars of creation within the Eagle Nebula. Webb's infrared view uncovered exceptional details of these enormous segments of gas and dust where new stars are born. The telescope's ability to see through the thick nebular material provided astronomers with clearer insights into the processes of stellar birth and evolution. Moreover, Webb's observations of galaxy clusters like SMAC 0723 and Pandora's cluster have shed new light on the large-scale structure of the universe by capturing thousands of infrared sources within these clusters. Webb has enabled space experts to study the growth and evolution of galaxies across cosmic time. The deep field images obtained by Webb not only expand our understanding of galaxy cluster dynamics, but also challenge existing models of cosmic structure and evolution. One of the most captivating revelations made by Webb is the presence of ancient galaxies that defy conventional cosmological theories. These galaxies, seen when the universe was just a fraction of its current age, have masses that rival or surpass that of the Milky Way. Such discoveries raise key questions about how galaxies formed and grew in the early universe. The James Webb Space Telescope, JWST, has rapidly become a focal point of cosmic exploration, significantly advancing our understanding of the universe. One of its most remarkable achievements is its ability to capture light from some of the earliest galaxies in the universe. This ability is grounded in Webb's advanced infrared technology, which allows it to observe celestial objects that are too faint or distant for other telescopes. Webb's observations have provided new insights into the formation and evolution of these ancient galaxies, offering a deeper understanding of the early universe. Recent images from Webb have shown galaxies in various stages of development and evolution. For example, Webb has captured intricate details of early galaxy mergers where two or more galaxies collide and interact. These mergers are critical events in the life cycle of galaxies, influencing their structure and star formation. Rates the telescope's detailed Observations of these processes are helping researchers piece together the history of galaxy evolution, offering a glimpse into how galaxies like our own Milky Way may have evolved over 4 billions of years. In addition to its observations of distant galaxies, Webb has also focused on nearby celestial objects, such as star-forming regions within our own galaxy. The telescope's ability to see through thick interstellar dust has allowed astronomers to study the birth and development of stars in unprecedented detail. For instance, Webb has provided new views of regions like the Orion Nebula, one of the closest and most active star-forming regions to Earth. These observations are helping researchers understand the complex processes involved in stellar birth and the formation of planetary systems. Another significant area of research enabled by Webb is the study of exoplanets. The telescope's infrared capabilities are particularly well suited for analyzing the atmospheres of exoplanets, allowing researchers to detect and characterize their compositions. Webb has already begun investigating the atmospheres of several exoplanets, providing data on their temperature, atmospheric composition, and even potential signs of habitability. This information is crucial for identifying planets that could support life and understanding the conditions that may influence distant worlds.